This simulation on the left shows a diagram that plots pressure versus composition for two immiscible liquids. And on the right is a piston and cylinder that represents the relative volumes. In this case, liquid at the bottom as blue represents water, and then red represents benzene. If I move the composition, of course, the relative amounts will change. Important thing to notice, this is the log of the volume. I can select show labels. It will just label what these two regions are here in addition to the vapor and the two immiscible liquids. And then I can change the piston height, which will decrease the pressure under some conditions, but when I get to this pressure, remember doing everything at constant temperature, when we get to this pressure, now we'll get vaporization without the pressure changing further until all the benzene has evaporated at this condition. I can also change the temperature in this simulation, and what the temperature change is going to do is going to move these phase envelopes, because when I change the temperature, I change the saturation pressure. So let's look at the simulation to get a better idea of this vapor-liquid equilibrium. In this simulation, if we change the temperature, then we move the curves that separate the phases because we're changing the saturation pressures. If I change the benzene composition, we can see the relative amounts in the log of the volume, and perhaps it's easier to look at the bar graph. I change the composition just from the lever rule, the relative amounts of each of the liquids. As I increase the piston height and lower the pressure, nothing happens until I get to this point. At this pressure, now and I'm going to more slowly do this by using the Alt key, as I continue to raise the height, the pressure's not changing, but notice I'm vaporizing, preferentially benzene. So eventually all the benzene has evaporated. Now I'm in a region where the liquid is water and the vapor contains both components with this composition. As I continue to raise the piston, I'm lowering the pressure and evaporating more of the water, and therefore changing the composition. And the relative amounts shown here are given by the lever rule, and then we also see this in the piston and cylinder, the liquid at the bottom and the vapor above it. The labels here just allows us to indicate the regions where this is liquid water plus vapor, this is benzene liquid plus vapor. And so this pressure composition diagram is for immiscible liquids, where we can have either two liquids present, we can have one liquid, and a vapor, we can have vapor present.